Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn how to use z-scores to find probabilities. Okay, so remember our z-score formula is z equals x minus mu divided by sigma, which means our x value minus the mean divided by the standard deviation. Then if I want to find the probability, so in this example, we're using the normal distribution tables, which find the area at or below a value on the normal curve, under the normal curve. So if we have a z-score of 1.02, I'm going to look at the table. I'm going to find in the z section 1.0 and then going across the top 0.02. So 1.02 come together, and whatever that value is the probability, right? So the probability of the area being 1.02, a standard deviation of 1.02 or below, is 0.8461 or 84.61%. So we're going to do a couple problems working forwards, and these are a little bit more of the more challenging ones, and we'll do a lot more of the simpler ones in class as well. A survey indicated that the average person spends about 28 minutes at their 6-month dental cleaning with a standard deviation of 7 minutes. The lengths of dental cleaning visits are normally distributed. Find the probability that a cleaning takes between 25 and 32 minutes. All right, so first I'm going to go ahead and draw this normal distribution. They told me it has a mean of 28 and a standard deviation of 7. So I'm going to put 28 here, and I'm going to add 7 to the right, subtract 7 to the left. All right, I want to be between 25 and 32, and I want to find that area in between. So I'm going to find the area below 32, then I'm going to find the area below 25, and I'm going to subtract to get the difference, which will leave me what's left, which is what I'm trying to solve for. So for 32 and below, that z-score would be 32 minus 28 divided by 7. So my x value is 32 minus my mean of 28 divided by my standard deviation of 7. That works out to be 0.57. All right, so now I'm going to look at my table, and so I'm looking for z-score of 0.57. So I'm going to zoom in on this a little bit. 0.5 is right here. 0.50, 0.51, 0.52, 0.53, 0.54, 0.55, 0.56, 0.57 is right here, this value. Whoopsies. Okay, so I went down to 0.5, over to 0.7, and I found that value. So 0.7157. So the probability that z is less than 0.57, that z-score, is 0.7157. And I'm going to do the same thing for when x is 25. I'm going to find the z-score. So z is equal to 25 minus 28 minus 7, which gives me 0.43. All right, negative 0.43, excuse me. So now I'm going to use my table, and I'm going to be looking at this one over here that has the negatives. I'm going to go down to negative 0.4, and I'm going to go over to 0.03 and find that probability. Okay, so the probability that z is less than negative 0.43 is 0.3336, or 33.6%. Well, I wanted the probability in between those. So I have the probability everything below 32, everything below 25. If I subtract the probability from the 32 one and the 25, I'll get the probability that's in between. So when I subtract, I get 0.3821, or 38.21%. The next part, it says find the probability that a cleaning takes over 36 minutes. All right, so kind of similar to when we were doing binomial distributions, we had to find the lower part and then subtract it from 1 to get the upper part. We're going to do the same thing here when we're using the tables. So 36 would be right about here, just over 1 standard deviation, and I want to shade everything above that. So when I find the z-score, I'm actually going to be finding 36 and below. So 36 minus 28 divided by 7 gives me a z-score of 1.14. And then I'm going to use my tables, and I'm using this one with the positive ones, 1.1, and then over to 0.04 to find the probability. All right, which works out to be 0.8729. That gives me the lower section. All right, I want the upper section. I want over 36 minutes. So I'm going to subtract that from 1, and I get 0.1271. Hopefully you'll realize, like, if you forget to do that, like, that doesn't look like I shaded in 87% of my graph, right? I definitely shaded in less than 50%. So that might tell you, like, oh, I need to do the 1 minus part on there. All right, working backwards and percentiles. Find the z-score that corresponds to the cumulative area of 0.3632. All right, so if I have the cumulative area under the curve, I can look in this section of the table, and I'm looking for 0.3632. 0.3632 is right here. And so I'm going to go over, it's negative 0.3, and then up, it's 0.05. So it's negative 0.35 is my z-score. All right, the next one, find the z-score that corresponds to the cumulative area of 0.9979. So if the area under it is bigger than 50%, you're going to be looking at the right side table on your table worksheet. If it's below 50%, you're going to be looking at the left one. All right, so I'm looking in the middle section for 0.9979. If that value is not there exactly, you'll pick the one that's closest, and then you go over and up and find the z-score that corresponds. For this one, it was 2.86. The other one, it says find P85. So that means find the value that would be the cutoff for the 85th percentile. All right, so I'm going to be looking inside of my table for an area of 85%, 0.85. There isn't one that's exactly 0.85. There is 0.8508. So that one is the closest. And so my z-score is approximately 1.04. All right, go Seahawks.